In this section, we'll look at properties of soil, including chemical, physical, and biological properties, and we'll also start discussing some of the soil degradation and problems with soil erosion, etc. The physical properties of soil are extremely important to overall soil quality. When we look at the qualities of soil, we're going to be doing some soil testing in the lab. Think back to when we did water testing, and when we did water testing, we looked at both chemical and physical characteristics of the water. We looked at how clean it was, um, if you could see through it, and we also looked at the chemical makeup of the water, and we looked at some biological things too by looking at the fecal coliform. We're going to be doing a very similar thing with soil, similar but yet different at the same time. Physical properties of water include two main characteristics. The first is texture. And you may just think that dirt is dirt, but dirt does vary tremendously from region to region, and even within a region there can be many different types of soil. Texture is determined by the mixture of sand, silt, and clay that makes up a soil. Sand, silt, and clay each are various sizes. Sand is the largest size particle, silt is medium size, and clay are very, very fine particles. Clay feels very, and you maybe used clay in art class, it has that real slippery feel to it between your fingers, whereas sand is that very coarse texture, and silt, maybe something you're a little bit less familiar with, is really something in between. If you've been near a pond or a stream, a lot of times the material that's like along the stream bed would maybe be considered silt. One of the experiments we'll be doing is taking a soil sample, combining it with water, letting it sit overnight, maybe even 2 days, and letting the soil separate, because it will separate by differences in density, and then measuring the percentages of sand, silt, and clay in the soil sample. Very important in regards to what types of crops grow best. Some crops like a lot of sand in them, some like a lot of silt. Not too many times are you going to find too many crops or plants that like a lot of clay material, but having that right combination, so because the clay is very good at holding in moisture, that's a good characteristic, but too much is a bad thing. A second quality is the porosity. Um, This relates to water retention in the soil, so the porosity depends on the texture. Sand is the most porous, clay is the least porous, so sand lets the water flow through it very, very quickly. Clay, again, holds on to that water, so the porosity is related to the texture, essentially. You really do need a good mix to have good quality soil. Typically, the ideal soil for most things would be a 40% sand, 40% silt, and 20% clay. When you have that mixture, that type of soil is given a name called loam, L-O-A-M. This next chart shows you all of the different types of soil that there could be. If you look at the very, very extremes, on this part of the triangle we have clay, this very bottom corner we have sand, this very bottom corner we have silt. Getting different ratios of those, we have different types of soil. So over here, if you're over in this region, you have a sandy clay soil. Over here you have a silty clay soil. In the middle you've got a clay loam. Here you've got a medium loam. And this is really pretty much the type of soil that you would be the best for most purposes. Again, some things do tend to like a little bit more sandy soil. This chart is probably a little bit confusing. It's known as the soil pyramid, and how you read it, each one of these numbers across the side are percentages. So this is the percent clay from 0 to 100%. This is the percent sand from 0 to 100%, and this is the percent silt from 0 to 100%. The clay amount is read as a horizontal line, the silt is read as a diagonal line this direction, the sand is read as a diagonal line this direction. So if we were at a point that was right here, well, let's go to some place that's a little bit more interesting than that. Let's say right here, this would be a soil that would be 20% clay, 70%, if I'm reading that right, 70% sand, and just 10% silt, right? So reading the 20% from this direction, the 70% from this direction, and the 10% from this direction. So when you do your soil testing, you'll be figuring out your percent compositions of each, and then using this chart to figure out, is it a sandy loam, is it a medium loam, is it a clay loam, etc. Looking at the chemical properties of soil, this is where we start thinking about the nutrients that are within the soil and how they will react. An important property is known as the cation exchange capacity, or CEC. This is the ability to absorb and release cations being positive ions. These could be calcium ions, sodium ions, potassium, magnesium, um, minerals that are important for plant growth. The clay particles, anytime you have clay, they attract positive ions, and that's because the clay, guess what, is negatively charged overall, so it's going to attract a positive charged cation. Usually a high cation exchange is desirable, but too much clay holds too much water, and there's going to be less oxygen because the clay particles are really small and they're compact, and so you also get less oxygen. So even though we would like to have that high ability to have lots of ion exchange happen, if we have too much clay, then that just brings too many other problems along with it. Some of the soil bases that we have, things that are basic solutions, you may have heard the terms alkali soil. That means that there are a soil that is a basic solution. Those usually contain calcium ions, magnesium, potassium, sodium, and we can help neutralize the soil acids with aluminum and hydrogen. Acids typically are bad for a lot of plant growth. It depends again a little bit on what type of plants you want to grow, what sort of pH they would want for the soil. Base saturation means that the proportion of soil bases to soil acids, and that's usually given as a percentage overall for the ratio of bases to acids. Another very important part, in addition to the chemical properties, the physical properties, are the biological components of soil. For most soil to be active, we need some biological activity going on in them as well. We need some fungi, we need some bacteria, we need protozoa, we need rodents, earthworms. All those things that are going to move through the soil, help decompose the organic matter, help break up and allow weathering and get that soil aerated and provide that air spaces and pore spaces in the soil. All those are also vital components of the soil overall. Next, let's move on to soil degradation. And we have talked about this some with our unit on agriculture. We'll continue to talk about it here in this particular unit with soil and soil properties. Soil degradation can be caused by a number of factors: wind, water, ice. It is a natural process, but typically it can be accelerated by human activities. And overall, it just reduces the amount of soil. We can do that by just losing the soil, making situations where wind can have more effect, where water has more effect, etc. Anytime we reduce the amount of soil, we then are going to decrease our production. We're going to have to increase our use of fertilizer, and that's all mainly because of poor agricultural practices, removing plant material during construction, clear-cutting forests, all of that causing more and more erosion. Here you can see a couple examples of what can be done for that. Oftentimes we have a construction site, and this was evident, I know it's been a year now or so, but when they were adding the Target up at the mall, along the hillside along Route 19, you could see that they had big bales and a fence to hold in all the material so that there was less erosion and no topsoil running down onto the highway, as opposed to something like this, which is a clear cut, where all the soil is just basically barren and you're going to get a lot of erosion in those instances. One of the main problems with soil erosion, all that sediment, is going to go downhill. Gravity's going to take it downhill with the water. It's going to affect streams. That's going to cause more turbidity. in the streams. It's going to affect water quality. If the soils contain pesticides or fertilizers, that's going to get into the stream. That's going to cause harm. Overall, just basically plant cover helps protect the soil. Those roots hold all the soil in place, and any leaves, things like that, all that's going to lessen the impact of rain and cause less erosion. Just a year or so ago, there was a big slide on McCardle Road up in the Mount Washington section of Pittsburgh. Many people say that that was possibly caused because there was a lot of tree removal that was going on the hillside, and that was maybe perhaps what prompted that big slide in that area. There was also a recent slide in Washington State, a very serious incident there that's just in the news in the last week or so. Not sure if that was an erosional process, as some say that there was a lot of homes built on a very unstable hillside, and that they shouldn't have been built there. I'm sure that's something that will be investigated down the road, but right now we just hope for the people that are in that area. The Dust Bowl of the 1930s, of course, very tragic example of soil erosion across the U.S. Your textbook has a really good summary review of what happened in the Dust Bowl, and I'm sure maybe you've learned about it in your history classes as well.